Hi everyone, make sure that we start on the 2.8 notes today, not the 2.7. So just go ahead and flip through it. And all we have today is two proofs, and that's it. So first of all, it says angle 1 is congruent to angle 2. Prove angle 1 and 2 are right angles. So remember that we are writing out and numbering. So angle 1 is congruent to angle 2. That's our given. Okay. And if we look at the diagram, we can assume that angle 1 and 2 form a linear pair. So angle 1 and angle 2 and we can just go say assumed from diagram. Okay, and then from there, what do we know about linear pairs? We know that they are supplementary. So angle 1 and angle 2 are supplementary. How do we know that? Use what you just found, right? So if two angles form a linear pair, then they are supplementary. So use the previous statement for your if, and then the next statement for your conclusion. So if two angles form a linear pair, then they are supplementary. All right, so we know now that angle 1 and 2 form a linear pair, and they're supplementary, and we know that angle 1 and 2 are congruent. This is known, what we're going to use next, as the right angle theorem. If you have those two conditions, that they are supplementary and they're right angles, that they're congruent, you can say that they are right angles straight from there. So angle 1 and angle 2 are right angles. Okay? And we would say, because if angles are supplementary and congruent, then they are right angles. Think about why that's true. So if you have 180 degrees and both angles are congruent, the only way that's possible is if they're both 90 degrees, which would be a right angle. Okay? So let's go ahead and write that out in our right angle theorem. So if angles are supplementary and congruent, then they are right angles. Okay? So that is known as the right angle theorem. Okay, and then in our next proof, we have that XR bisects angle YRZ. So what I've been stressing to you guys is, what does bisect mean? So, maybe write a little note over here about how this is going to give me two congruent parts. So I know that somewhere in my reason I need to talk about two congruent parts. And then I'm trying to prove it's perpendicular. So how do I show that something's perpendicular? I do that by showing that segments form right angles. All right, so we have the beginning. We know that we're going to talk about something with congruency, and we have the end that I need to show that the segments form right angles, because if they form right angles, then I know the segments are perpendicular. So let's go ahead and start with our given. Okay. And what does the given tell us? The given tells us that we divide an angle into two congruent parts. So this is angle YRZ. Okay. So these two are going to be congruent. So angle YRX is congruent to ZRX. Remember, use the previous statement as your if, and then your next statement should be your conclusion. So if a ray bisects an angle, then it divides it into two congruent parts. Okay, so I know that those two are congruent, and kind of thinking about the previous proof, we know that YRZ is a straight angle, which means a line. So is there somewhere I can start working with right angles? The right angle theorem. So I need to prove that these are right angles. So we're going to say that angle YRX and angle ZRX form a linear pair. How do we know that? That came from the diagram. Okay. And if two angles form a linear pair, what does that mean about their measure? Well, we know then that they are supplementary. How do we know that? Again, use the previous statement as your if, and then the statement that you just wrote as the conclusion. So if angles form a linear pair, then they are supplementary. All right, so we proved up top in step 2 that they're congruent. Here we proved that they're supplementary. This is where we're going to use our new theorem, the right angle theorem. So angle YRX and angle ZRX are right angles. How do we know that? Well, if angles are supplementary and congruent, then they form right angles. Which is exactly what we were looking for. Okay, if we go back up top, I said to show that something's perpendicular, I have to show that they form right angles. Well, look at the very last thing I just wrote. Forms right angles. So XR is perpendicular to YZ, and that's because if segments form right angles, then they are perpendicular. Okay, and remember that the very last thing you write should be what you're trying to prove, which it is. Okay, I hope you guys are starting to make the connection that, this statement is the if part. Then the next statement is the conclusion part. Okay, if we jump down, we have that this is the statement. That's the if part. The next statement, supplementary. They are supplementary. And we could keep going on like this, right? So then I could do this as the next if they are supplementary. And then here we go. Okay? And then finally, we have right angles. Prove my last statement. So hopefully you guys are seeing the connection between using the statement as the if for the next part, and then the conclusion should be the statement that you're writing. As always, thank you so much for watching, or listening, or both.